All right, everybody, we're on 11.2, switching between forms. So we've talked about graphing from standard form. That looks like something like this. That's standard form. Y equals ax squared plus bx plus c. And we also learned how to graph from intercept form, which looks something like this. All right. Today we're going to be learning how to switch between those forms. So if I give you an equation in standard form and you want to move it to intercept form, well, we know how to do that, or we will learn how to do that. And if we have something in intercept form and we want to put it back into standard form, well, we're going to cover how to do that. And the way to do that, you've already done this before. So it's just kind of like a review. This is basically a review. All right, so before we get any further, before we learn how to switch, let's do a quick review of graphing from each of those forms. So this is standard form. Standard form is y equals ax squared plus bx plus c. And typically, to be able to graph, the first thing that we need to do is find the axis of symmetry. So to do that, we would label down what A, B, and C are. So A is 1, B is 4, and C is 5. And then we were able to find our axis of symmetry, which is x equals negative B over 2A. And we substitute what A and B are. So that's negative, and we put 4. And we divide it by 2 times A, which is 1. So we'd get negative 4 over 2, which gives us negative 2. So our axis of symmetry is right here. So that's half of the way. We have our x. This is our x for our vertex. We need to find the y for our vertex. And again, if we have an x and we need to find a y, we substitute. Okay, so we substitute that negative 2 into our equation for x. Whenever we have an x, we're going to put in a negative 2. Okay? All right? So that would end up giving us, plug that in your calculator or simplify it by hand, and we'll end up getting 1. So from those two, that gives us our vertex, which is negative 2, 1. So here is our vertex. And then from there, we just use our growth pattern. Since A is 1, the parabola is going to open up. We're going to go up, and we'll go over 1, up 1, over 1, up 3, over 1, up 5. Connect the dots. Put arrows on the end, and you're set to go. Let's write down these key features. For the x-intercepts, there's none. It doesn't cross the x-axis, doesn't cross this line at all, so we don't have any x-intercepts. Y-intercepts, it looks like it would be 0, 5. And again, we can find that by looking at our constant. And that only applies if it's in standard form, okay? Axis of symmetry, we already figured out what that is. It's x equals negative 2. Vertex, we already figured that out. Here, the vertex is a minimum. And how low does it go? It goes down to 1. So again, it's like you're going on a walk. These are your heights as you keep going until you reach this lowest value, which is 1. Okay? And then direction of opening is up. All right, so that's a quick review for graphing from standard form. Okay? You can always refer to our previous videos or notes to help with that. This is in intercept form. Again, that is something like y equals a, x minus p, x minus q, where p and q are your x-intercepts. And again, x's tell lies. It's the opposite of what you'd think. So our first step here is to identify and plot the x-intercepts. So the x-intercepts here are going to be 1, 0, and 7, 0. Again, it's the opposite of what you would think. So we'll plot those here at 1 and another at 7. We need to find the axis of symmetry, so that's our second step. This one we don't need to use the negative b over 2a, and in fact we can't use that. We don't know what B is. All right, so what we'll need to do is we'll find the axis of symmetry is halfway between. So halfway, that gives us 4. So we have x equals 4 is our axis of symmetry. Okay, step 3, we need to find the y for our vertex. So this is the x for the vertex. Now we need to find the y. And we substitute. So we have at negative already, we'll put 4 minus 1 and 4 minus 7. That will give us a negative, and then a 3, and then a negative 3. So it looks like it gives us a 9. So our vertex is 4, 9. And it was 4, 9, 4, 9, positive 9 up here. And our direction of opening goes down. A is negative, so we're going to go over 1, down 1, over 1, down 3, over 1, down 5. We already have that x-intercept. Over 1, down 7. If we wanted to continue the pattern, 1, 3, 5, 7. Again, it's just all odd numbers. Okay. Connect the dots, and we're good to go. Okay, x-intercepts, we already have those written here. Okay, y-intercept is 0, negative 7. Axis of symmetry, we already wrote that down, x equals 4. Vertex, we already wrote down, which is 4, 9. We have a maximum value of 9. Again, it's how high or how low it goes. So it's always it's based off of your y value. And it's always like the y value of your vertex. Direction of opening is down. Okay, so there's a quick review for graphing from intercept form and from standard form. Okay, now let's learn how to switch between forms. Now we've covered how to graph two forms of the quadratics, standard form and intercept form. Sometimes it's more useful to be able to have a quadratic in a certain form. So today we're going to learn how to switch between those forms. All right, so let's start with standard. If you look at this, and we want to write it like this, okay? If we want to go from standard to intercept, what we need to do is we need to factor. We kind of look at the intercept form, it's been factored. Sometimes it's called the factored form, okay? We get those two parentheses. If we need to go from intercept form to standard form, all we need to do is distribute. Okay, use the distributive property. Okay, so we would distribute like the 3, and then after that we could like distribute something like this. Okay. All right, so let's just do some examples. Again, all of this you've done before. Maybe it's been a while. Okay, so it says switch the following equations into standard form. So all of these are already in standard or intercept form, and we need to distribute to solve. Okay, so using the distributive property, we would multiply everything to everything. So x times x gives us x squared. X times 6 gives us plus 6x. So give us a negative 4x, and this would give us a negative 24. And then we just need to combine like terms. So we'd get y is equal to x squared plus 2x, that's from here, minus 24. And that's it. So we just need to distribute to get back into standard form. All right. Again, all we need to do is distribute. So we're going to distribute this negative x. We'll get y is equal to negative x squared. And then negative x times negative 10 will give us a positive 10x. Okay, so sometimes you only need to distribute like one time. I mean, I guess twice. Here we do it like 4 times. But okay, and then one more. Why don't you pause and give this one a try? Again, you can use a box method if you prefer. So maybe we'll do it for this one. If you can remember how to do it. We've always been, like recently, we've been doing it backwards. So here we'd have x plus 3 and x minus 5. and we just do a multiplication table. So x squared, 3x, negative 5x, and negative 15. And then we just combine like terms. So we have x squared. Here we have a negative 2x, and then a negative 15. Okay. All right. Here's some more examples. If you feel inclined, you're welcome to do those, or you can skip past here. I'll do them, but just in case, you're welcome to go past. You may want to skip, or at least do D, so make sure you go and look at D. All right, so here we need to distribute. We basically have three things. We have this, we have one of these parentheses, and one of these parentheses. So we're going to need to distribute even more than what we've done before. What I'm going to do is I'm going to do this part first. You could distribute the negative first, but I'm going to do it more like what we've done before, doing this first, okay? So here we'd do x times x is x squared. That gives us a positive 2x. This gives us a negative 2x. And this gives us a negative 4, okay? But then we need to remember that we have this negative out here in the front like this. We could combine like terms. These two will cancel, so 4x or 2x minus 2x will give us 0x. So we just get something like this. And then we need to distribute that negative. So we'd end up getting y is equal to negative x squared, and then we'd have a positive 4. Okay. All right. E, same sort of thing. Why don't you pause and give this a try? All right. Maybe I'll use a box method this time. So we have x and 3 and x and negative 4, x squared, 3x, negative 4x, and a negative 12. Combine like terms, so we have x squared, negative 1x, and negative 12. But we still have this leading negative that we have. We need to distribute that. So we get y is equal to negative x squared plus 1x, and then a positive 12. Okay? All right, and then with D, again, an exponent is telling us how many times we're multiplying the base. Okay, so it might be more useful to rewrite this as x plus 3 times x plus 3. Okay, we're multiplying the base by itself 2 times. All right, so here I'm just going to use the distributive property here. We'll get x squared. Here we get plus 3x, another plus 3x, and then a plus 9. So we'd get y is equal to x squared, combine like terms, and we're good to go. Okay, so this is switching from intercept to standard form by using the distributive property. All right, okay, and now we're going to do a couple examples of going the opposite direction, going from standard form to intercept. Again, that is, to do that we need to factor. All right, so this is why I've been adding these types of problems onto your homework at the end to help you keep and to remember how to do this, okay? So this is where we do glasses, and we need to find the two things that multiply to give us 15x squared. So what multiplies when we do glasses, okay? And need to add or subtract. I always write addition, but it could be subtraction to give us negative 8x, what gives us the middle term, okay? All right, so I think it's always a great idea to write down a factor pair, so 1 and 15, or 2 doesn't, but 3 and 5, and that's all of our choices. So we do 3 and 5, looks like both would need to be negative. So maybe I will erase this plus, and I'll do negative 3 minus 5, okay? And negative 3 times negative 5. Okay. All right, so at that point, We found those two things, and we're just going to substitute that in for what negative 8x is. So we'll do x squared minus 3x minus 5x, which is just the same as negative 8x, and plus 15. Okay? And then, again, you can choose what way you want to do it. I'm just going to cut it in half. Greatest common factor for the left side. Looks like the only thing we could take out would be an x. We need to write down what's left, so that leaves us with an x and a negative 3. On the right side, looks like we could take out a negative 5. Can't take out an x because there's not an x in this term. Okay? So here we'd have x, and then 15 divided by negative 5, that gives us a negative 3. Again, these two need to be the same, and they are, so we can factor that out. And then what's left is the x minus 5 from here and here. Okay? Y equals, don't forget y equals an equation now, and we're set to go. Okay? All right. Feel free to pause any of these, especially at least give C a try. This one's a little different, but again, if the constant's missing, all you need to do is take out the greatest common factor. So here, it looks like we could take out an x, and that would give us with x plus 10. And we're done here, okay? All right. Again, please pause this one. Give this a try if you can. This one is a little tricky because we have a leading negative. And again, we've talked about this, where if we have a leading negative, we need to take that out first. If you don't, it's going to mess up your signs, okay? So let's take out a negative. You could take out a negative 1 if you want it to be a negative 1. But then we'll need to divide everything by negative 1. And when you do that, it'll just change all of your signs. So here we'll get a positive x squared, a negative 2x, and a positive 1. Okay? All right? And then we just need to do our glasses part. So two things that need to multiply to give us 1x squared, and add or subtract to give us a negative 2x. So I think the only way we can make that work, how can you multiply two things to give us 1? Well, it's got to be 1 and 1. But if we look at the signs, this needs to be negative 2. So both of these need to be negatives. Okay? And then we'll substitute in. So x squared minus 1x plus 1. And then, again, we have this negative, our greatest common factor. In the past, I suggested to write that out first and write your two parentheses, and then that way you don't forget. Okay, I'm going to use the box method just to mix it up. Okay, so we'll do x squared, negative 1x, and 1. Okay, greatest common factor for the top row, looks like we could take out an x. Here we could take out a negative 1. For the columns, we could take out an x and a negative 1. So we should have x minus 1 and x minus 1. Okay, you're always welcome to distribute and go back and make sure that they are equal. That's one way you could check. Okay. So again, keep in mind that if you factor the negative 1 out first, it still needs to be in your answer at the end. Okay? Mind those signs. I feel like it's probably one of the most common mistakes is just these little sign errors. So be careful with those, okay? All right, well, if you have any questions, let me know. If you need more examples of factoring, you can go back to our factoring unit. All right, we'll see you guys.